Yeah, I'm going to start the recording now. At least we're not that deep into the Euler-Lagrange equations. So we're going to talk about the formalism that will allow us to obtain the equations of motion for different systems without any thought of how do the forces project onto each other and so on. We don't need that. We only need to calculate the potential and the kinetic energy. And that's everything we need, basically. So I'm going to outline the framework to work with dynamical systems. And we're not going to prove that it's working because that's a whole different course on theoretical mechanics. So now we're going to use these instruments, not prove that they are really working. We just assume them to work. Like the limits and functions, we're just using them. So,
Hi, Elia.
yeah.
Just I have an urgent thing to do. I need to go, and
Okay.
whenever I can come back, I will come. Okay.
Okay. Yeah. Okay. See you
Thank
then.
you, Elia. Thank you. Yeah.
Okay. So let's say that this is the kinetic energy of the system. We're talking about basically any kind of system. So we can consider this system with one pendulum. We can consider another system with two pendulums and a spring. It could be three pendulums. The system of equations will hold nevertheless. So this is the kinetic energy, and this could denote the potential energy. This is just the standard notion, so we can use that. And I'm going to introduce a thing that is called Lagrangian. It's kinetic energy minus the potential energy. And for each specific system, we can find out the formula for kinetic, for potential, and the Lagrangian. Yeah, we can basically find that as well. And also we have to introduce a thing that is called generalized coordinates. They're generalized because they are basically generalizing the notion of linear coordinates. Now we have two types of coordinates, linear and rotational. So here we have 1 degree of freedom. This pendulum could swing around this axis. And the state vector is of dimensionality 2 times 1, because we have the coordinate on this axis and the velocity on this axis as well. So, yep, for one generalized coordinate, we're going to have one equation of motion. If we would have two generalized coordinates, we're going to have two equations of motion. And the trick comes here. So the theory of Euler-Lagrange equations says that we can obtain the equations of motion for the system by doing the following. We can take a derivative by dt from the partial derivative of the Lagrangian by the coordinate by theta dot by q sub I dot, where this is the generalized coordinate number I, and yeah, basically that's its time derivative. And here's the second part, the partial derivative of the Lagrangian by dq sub I, and this is equal to 0. So it should be very scary and very unclear. Am I right? Also, just a quick question. Mm-hmm. That's a good question. Okay, so let's talk about that. Would it be comfortable for you to connect with your voice at least? I think, I mean, we can have a discussion. There are not so many people, so we can just talk. I can tell you who I am and why I even here and so on. What do you think about that? Yeah, sure.
Hello, can you hear me?
Hello? Uh,
Hello.
yeah, I can
Yeah,
hear
can you
you.
hear me?
Yes, yes, I can.
Okay.
Uh,
Hi, it's Nashik.
so you're a student of KU, right?
Yeah, me and my friend got recommended by one of our other friends who like sent us a link and told us to join. All she told us is that this is some sort of robotics competition that's like ongoing continuously or something like that.
Mm-hmm.
I'm not sure. We had zero information for
Yeah,
coming here.
kinda. So my name is Ilya. I'm from Moscow Institute of Physics and Technology from Russia, and
Nice to
we're
meet you.
nice to meet you too. So we're doing robotics here, and we are collaborating with Khalifa University on this topic, basically. We were delivering a summer internship in summer for KU students on computer vision. Then we have had a course on computer vision. And generally speaking, we are here to work with robots. Let me show you the robot. Just a sec. Here. So have you
Oh,
seen
that's
them?
cool. I think I've seen them around in the Innovation Day and stuff, but not
Ah,
really. No.
yeah. So these are the humanoid robots that we are working with, and they are playing football autonomously. So we don't control them. And the plan is for the Khalifa University to have their own team of robots that are basically like these ones, but just slightly different. And this is the reason we are gathering. We are uh, trying to go through all the necessary steps to for KU to participate in the competitions in robotic football, which were held worldwide from 1996, I believe. So this is a big thing in robotics, and KU is rapidly entering
Oh, that's cool.
this field. Yeah, so the plan is to work with me regarding the theory. I was delivering computer vision previously. I'm going to deliver control theory now. And there is also a colleague of mine, Fedor. He is in person in KU, and he is going to show you and the other students how to start the robots, how to repair the robots, and so on. This is the very bird view of what's going on. So there's a certain place in KU where he is sitting every day, and you can come there and learn how to run the robots so that they can play football autonomously. That's the idea.
Okay, that's really cool actually. Do we need to have some sort of basis to get into this? Because both me and my friend are first years, so we don't have a lot of experience with
Ah, you're from the first
robotics
year,
in general.
really?
Yeah, both are first year.
Wow, wow. Cool. That's cool. You have a lot of things to do still, but the only thing that is really
Yeah.
required is the curiosity. And if you want, you can enter the team. Why not? So the people who will have the most initiative will basically go to the competition, which is just 2 months from now or something like that. So if you are very curious, you can start working towards being in the team. Then you can enter the team. You can work with the robots, with the hardware, software, vision, neural networks, whatever. So the only thing that is required is curiosity. If you know basic Python, it's a nice thing to
Yeah.
do.
Oh, okay.
Ah, yes,
Okay.
awesome. So basic
Thank you.
Python is it really fits. What else? Well, basic math. So everyone has that. I mean, there's nothing really special. It's just robotics is an intersection of everything, like applied mathematics, computer vision, computer science, data science, machine learning, and robotics is in the middle. So you'll probably have to work with some kind of wiring or electricity, but that's not necessary. So we do fewer of that than you can expect. I mean, we're doing robotics, but we're not welding stuff all the day, all the time. We're more programming things.
Okay, I will tell her about it. I think we'd really like to try learning robotics. It sounds fun.
Cool.
Thank you
If you,
for
yeah, sure. So you don't really have an idea of what's going on, right? So
explaining.
I mean, I can show the introductory presentation. Why not? Because
So much. Yeah, I
anyways,
would. Thank you.
we don't have many people today, unfortunately. So why not?
Sure, I would like that if you don't mind.
Yes, no problem. I'm going to share the screen and
Sure.
tell you about my team. And the KU team will be something along those lines, I believe, when the team will be ready. I mean, when there will be enough people and so on, it will be something of that kind. Since we have this format of discussion, you can interrupt me at any point. I will be glad to hear your questions.
Okay, thank you.
So my team is Starkit from Moscow Institute of Physics and Technology, and we are doing robotic football from 2018. Our team was founded by a guy who finished our university a long time ago, 1988. So he's a successful businessman, and at some point he thought of opening a team in his alma mater. Since that moment, we are doing robotics and we're competing in football, basketball, marathon, sprint, obstacle avoidance, weightlifting, archery, and triple jump in a physical world as well as in the simulation. Here we have a photo of 3 our main robots. I think that, yeah, 2 of them are outdated. The ones that are to the right and to the left. So we have upgraded a lot, both of them.
They look really nice.
Hmm?
They look nice. Interesting.
Ah, thanks. So this robot that
Yeah.
I'm showing, it's with a stereoscopic vision, and the one on the left was monocular. So it had just one eye. And this is
So
part.
one of the like, sorry,
Hmm?
uh, just a quick question about the robots. Do
Sure.
the robots need arms if they're playing football? Like
Yes.
the two on the right?
So they can stand up autonomously using their hands, and also in some situations, in a couple of years, they will have to throw in the ball, for instance, using their hands. But the most important thing for now is the stand-up motion, because the robots are falling all over the place.
Makes sense,
Um,
yeah.
yeah. So now you can see the carpet, it's basically artificial grass, and it's kind of thick, so it's 3 centimeters approximately. And the robots are walking on this uneven surface, which is basically kind of unpredictable. So they can fall over, and then they will have to recover somehow. So that's
Yeah,
what
that makes
they need their hands for.
Thank you.
And another robots, the rightmost one robot, is also capable of playing basketball. So it's doing basketball like this. He's approaching the ball. It's standing on a pedestal, and he is moving the ball with one hand to another hand. Then he is moving his hand like this to the back, and then he's throwing the ball towards the goal post.
That's so cool. Yeah, that's really nice. Thank you for explaining.
Sure, sure. So this is part of the team. It's like 2/3 or something. So we have a bunch of engineers and constructors, so people who work with milling, drilling, physical assembly, and so on. They do the repairs, they do some of the difficult design parts, like the complicated milled parts that you can see over here, these structural elements. They are, I mean, they're just grown up, educated people, and they do other stuff apart from the team. But for sure, I have to count them as well as the part of the team. We have this one guy who is the founder. We have 3 PhDs. We have 3 PhD students. I'm one of them. And we have a lot of master students and approximately end of bachelor students. So they're like 3rd, 4th year. A lot of them are working towards their bachelor theses with the team. And we participate in events around the world, starting from 2019. Then we have the first competition, and after that we had a bunch more. Then everything was shut down because of COVID for a couple of years, and now we are going to places happily again. So this is from Brazil. We were competing there. We're competing in China. We're competing in different places, as well as we have invited teams to play in Russia. So here are 2 versions of this robot that I have shown you in person. It's approximately 7 kilos and approximately 70 centimeters in height. It has 20 degrees of freedom, meaning that it has 3 servo motors per hand, this one, and the elbow. The same symmetrically for the left hand, and in the legs, they have 6 servo motors. So are you familiar with the notion of roll, pitch, and yaw from aeronautics? What's basically your interest? So what do you study?
My major is mechanical engineering.
Mechanical engineering.
Yeah.
So do you know the roll angle, pitch angle, and yaw angle? Do you know that?
No, I'm guessing
Ah,
the ball. Oh, no.
Okay, so let me show you. The pitch is this motion in this vertical plane. So roll motion is this motion. And yaw motion is the motion around the vertical axis. And each leg, it has 6 servo motors. And it has 3 pitches for hip, knee, and ankle. It has 2 rolls for hip and ankle, and it has 1 yaw that is rotating the whole leg. So we have 6, 6 for the legs, 3, 3 for the arms, and it has also this degree of freedom, And this degree of freedom, in total, it's 20 degrees of freedom for a single robot.
Wow, that's nice.
Yeah, it has a computer. So as I said, it's completely autonomous. It could play on its own. And the robot is observing objects with its sensors and then reacting to these stimuli. They play.
It's AI vision detection, AI image recognition, computer vision.
Yeah, kinda. So I a little bit avoid using this abbreviation AI, but yeah, we use neural networks. We can talk about that for sure, because AI is an umbrella term. It's very broad.
Yeah.
Generally speaking, this thing is like a computer, but on the feet. So we treat it as a laptop. You can basically plug a monitor in, a keyboard, a mouse, and you can read. You can edit documents. So it's just an Ubuntu computer, a normal one, but it's just capable of moving physically through the world. So robots are just computers.
That's interesting.
And apart from the vision, it has the following sensors. It has pressure sensors on the feet. So when the robot is standing on the ground, it can find out if the pressure on a certain part of the foot is missing. So the robot has inclined, he can detect that. Also, he has an inertial measurement unit, IMU. It's a gyroscope and accelerometer. So the robot is understanding if he's accelerating somewhere and rotating. And also he has positional encoders in all of the servos. So he knows exactly the positions of each of the joints. And that's enough for him to plan his motions accordingly on the field. They work in teams 4x4. Let me show you around the lab. So I'm going to show you the field. It's dark in here, but when the robots are playing, we have the lights. So there are other robots lying around, and yeah, also there are people doing stuff.
Wow, it's
So
huge.
yeah, it's indeed huge, and we have also a second part of the lab that's over there, but there's a meeting of some kind, so I'm not going to go there. But yeah, so here we have a field and the whiteboards and stuff, and there we have the manual assembly, drilling kind of facilities, ironing, not really facilities, but just the instruments to work with beetle repairs. This is the lab. So we have 6 robots. These robots, they're called Starkit Autonomous Humanoid Robot, Sakhar. And it's also sounds almost like the same, like Russian for sugar. Also, we have a couple semi-alive little robots, couple more another little robots, and we have 10 robots of this kind that are in the middle. So they are off the shelf. We have bought them, and they are participating in competitions in a so-called standard platform. With these robots, with the carbon robots, with these black ones, we are participating in Humanoid League, which is for the robots that kind of resemble humans. And it means that their center of mass is supposed to be not too low. They have to have their proportions right. They have to have not more than 2 eyes, and they're not supposed to have any active sensors like radars, lidars, infrared lighting, or anything like that. So just the sensors that the humans have. Could you tell me if humans have everything that I've mentioned? Cameras, accelerometer, pressure sensors, and proprioception. What do you think about that?
I think they have all of it. Maybe not the accelerometer because they can't tell how, like in numbers, how fast they're going. But I feel like it's a feeling that maybe most people have.
We have an accelerometer. We can stand on one foot. Well, you don't see me doing that, but believe me. So I'm standing on one foot, and you know the feeling of moving, accelerating. It's because of the so-called inner ear. So that's a part of the head,
Yeah.
and we basically feel the accelerations. So we have everything that robots have, and we have even more. So we have vision that is effectively better than the vision of the robots. We have pressure sensors that are not just for sensors on the edges of the foot, but we have normal feet that can feel the texture, gravel, grass, whatever. We have tactile sensors. We have smell. We have understanding of voice and so on. We have much more than they do, but they do not exceed our capabilities. So they could normally participate in the Humanoid League. It goes in the and under the flag of, so to say, RoboCup. So RoboCup is a set of leagues. Humanoid League, standard platform, also the wheeled robots, and yeah, there are also other groups of leagues. So robotics is a big thing, but the biggest importance for us is the RoboCup, especially the humanoid RoboCup. But also there is a league that is called FIRA. So that is that stands for the robots that are very versatile. So they do many different things with the same construction. I have mentioned basketball, triple jump, marathon, sprint, archery, obstacle avoidance, and so on. And everything is supposed to be done with the same mechanical construction. So RoboCup focuses on the very complex problem of football, and FIRA focuses on a lot of simpler problems that I've mentioned. Yeah, you will be primarily focusing on RoboCup for now. Other robots, well, yeah, in the middle, there's a robotic dog that is walking on two hands. On the right, there's an off-the-shelf robot that is playing football as well, but in another league. And on the left, there's a previous version of a small robot that is participating in FIRA competitions. We have been world champions a couple of years ago, in 2021 to be exact. After that, we were not allowed to participate, unfortunately, but back then we were champions of the world in our league, humanoid kid size.
Congrats. That's cool.
Yeah, I think so. Unfortunately, we were not participating after that, but who knows? Maybe at some point, or maybe you will become the world champions. So it's totally possible to do. I hope for that because we are not participating.
Thank
And
you. Hopefully you
and
can participate next year.
also there were different events. We were participating in them successfully. I will not go through them because it could be boring, but anyways, there were some.
Thank you so much. That was very helpful.
Sure. About the course in Vision, I'm going to just briefly go through that. So what we were discussing is the role of the vision in robotics in general. How do we state the problems of detection? And how can we detect objects using color? Are you familiar with photography? I mean, with the figure of photography, color representation?
Yeah,
Ah, great.
I did do
So,
computer before.
you did computer vision.
Just not. just like to a basic level, image classification, machine learning algorithm,
Ah,
classifying.
that's awesome. That's awesome. So you're already familiar with half of the the stuff that we were discussing. But yeah,
Yeah,
so
just the basic.
we were covering color spaces, what are masks, how can we construct them. Also, we have a set of lectures that cover all of these things, and they are on YouTube. So we're going to make them public. I have obtained an agreement from KU to do that. I mean, to make them public, and you can check them. You can watch them if you want to. It's the vision, not control,
Wait,
but still they are.
how do we find it? What's the YouTube channel?
I'm going to share them in the chat. So yeah, you're in the chat, right? Already.
Yeah, yeah. Okay,
Great.
thank
So
you.
I'm going to share that. And first I am talking about classical vision, so just algorithmic processing and pattern recognition, about cameras, how do we find the distances to objects, and after that there's a second part that is about neural networks. A colleague of mine is talking about that. So here we're talking about different color spaces. HSV is another color space that is widely used in robotics. Here we're talking about the ways to process masks. I'm just rushing through the lecture, so it's not supposed to be that informative. I'm just giving a brief idea of what is the previous course about. After that, we are talking about analyzing certain shapes and sizes. So how can we distinguish between, say, this robot that is black and me that is black as well? So this robot is just smaller and it's not that dense, so it's visible through. So you can probably distinguish this robot from me. And we were talking about formalizing these notions. And the last slide is about the neural networks and the things that we cannot really do without them. We cannot dig infinitely deep into the little features of the objects. And if, say, this Lego rat is very close to the real rat, we'll be exhausted trying to formulate criteria to distinguish between them. And the neural network can do that using only the data. And on the right, we have an image of the person that was generated using a neural network. So this person doesn't exist, and the name of the website says so. So that's true. If you enter this site, if you visit this site, you can just refresh the page and the neural network will generate a new face each time you do that.
Yeah, I've seen that. It's crazy. It's cool.
Yeah. So we don't talk specifically about those technologies. They're outside of the scope. We're focusing primarily on robotics. But if there is some kind of interest in that, we can talk about generative neural networks, for example. We can do that as well. So that was about vision and about control. The plan is for us to use this kind of formalism. So will have to be more formal than with vision, basically, because vision was discussed kind of informally, and we were talking about images coming out from the camera to our program. We were doing programming, not proving anything, no theorems, no really difficult math, nothing like that. And control is a different animal because we have to describe the systems formally, and we have to establish the ways to work with them. So it's kind of rigorous, and it will require a lot of attention. But at the end of the day, it will all make sense in the context of the big picture. So one separate part for now is learning the real skills with Further, and another part is learning control with me. And after that, they're going to join so that you will become a professional in the field. That's the plan. So that was a very elaborate way to answer your question.
No, thank you so much. That was extremely helpful. I'm really excited to try and learn those. Thank you.
Sure.
And thank you for taking me through the presentation. I've caught up my friend who's joining with me, and we'll see you in your next lesson, I guess.
Yeah. We're having our sessions during the Ramadan from 9 to 10. And after that, we're going to have them from 18:30 for a couple of hours.
Okay.
And yeah, they will be home assignments and stuff like the normal course, but not in the official schedule. That's the plan.
Okay, that makes sense. Thank you.
Yeah, thank you. See you next time. And you can write me in WhatsApp if there are any questions or you're confused or anything. Or you can ask the guys that were in the team, Ahmad, Mohammed, Nasiba, Hajar, Bushra.
Yeah, Nasiba recommended us. She gave us a link.
Yeah. So we can ask them about the directions. So on. Thank you very much.
Thank you. Bye. Have a nice day.
And you. Bye bye.